Skewness. Skewness is a very interesting um, property or graphical measure when it comes to big data analytics. Um, there are certain features which skewness of the data covers, and they are important as a data analyst to know about. First, what is skewness? So, when you are concerned about the symmetry or distribution of the data, so how does your data values are plotted in a bar graph, area graph, or line chart? So whether its distribution is just like a plateau, like uh, a hill in the middle and the flat from the sides, or it has some zigzag kind of distribution. So in either case, you want to know about the distribution. Now, why it is important for us to know about the distribution of the data? Um, this is because you want to take certain decisions about which approach to take while applying or while mining that data. Um, Skewness defines um, whether your mean and median of the data are at the same point or are similar, or they are different. So that means if you have zero skewed data, that means it is not tilted on right side or left side. We will see the examples in the coming slides. So if you have zero skewness, that means it is a normally distributed data, and you can go with uh, the methods which support normal distribution of the data. Otherwise, if it is skewed towards a certain side, you will choose other methods which are good with the um, non-skewed left or right skewed data actually. So there are two types of symmetries: symmetrical or asymmetrical. Symmetrical means that data has same distribution on both sides of the mean and median. We will see the example. If your data is if your data peak is on the left side, then it is called as left skewed, and if it is on the right side, then it will be called as right skewed data. Right skewed data is also called a positively skewed, or left skewed data is also called negatively skewed. So, what is zero skew? Um, so, zero skew is something which is actually entirely symmetrical. The left and right side of the data are of the plot are mirror images of each other. Basically, it shows that your data has a uniform distribution, and let's take an example here. So this is a zero skewed data. Now the big thing here that how you can tell um that this is a zero skewed data when the mean and median of your data are similar. Like in this particular example, the mean and median of the data are, if not the same, but they are similar. They may not be exactly the same values, but they are similar. That means they are close to each other. So that shows that what does mean show actually? Mean shows that there are certain values which are larger than that value, and there are certain values which are smaller than that value. This is what mean shows. But what does median shows? Median shows that it is actually the middle value among, if you arrange or sort the all the data values, you just pick the middle value, and this will be called as median value. So when your mean is similar or same as that of median, That means equal number of values are greater than that value and or less than that value. That means equal number of values are distributed on either side of the mean. So this is called zero skewed. So that means it is not tilted towards higher side or lower side. We will see about in the coming slide that what is positive skewed, so you will understand. So this particular actually this kind of data shows that you can assume that your data is already in normal distribution. Your data is already in normal distribution. That means you don't have to apply when if you are applying for certain transformations like normalization, standardization, or other technique. So you might remember that we have to take into account that whether our data is has Gaussian or normal distribution or not. So according to that, we will go for either normalization or standardization process. So this shows that our data is normally distributed. That means it is equally distributed on both sides of the mean. Okay, so then we will discuss about right skewed, or it is also called as positive skewed. So basically, it the peak here is tilted towards the right side of the graph, and so it has long tail on the other side or left side of the graph. So if we look at the example, it will look like this. So this is right skewed data. Why does it called as right skewed data? Because mean is greater than median here. The biggest you can say evidence that your data is right skewed as you just calculate the mean and median. Even if you do not draw the graphs, so you can literally judge it by looking at the mean and median values. So why is it so that? It is because there are certain values. If you just look at the bottom of the graph, there are certain values which are on the higher end, or which can be called as outliers as well. So there are some values which are above, or they have abnormal range, or they are abnormal values, which makes the mean high, but which does not affect the median at all. So when you have very high value or very low value, the mean will be disturbed, but median will not be disturbed, because median is always the middle value here. So when your mean is greater than median, that means your data is right skewed or positively skewed. On other cases, when the situation is inverse, so it is left skewed, as shown in the graph. So here the story is that your mean is less than median. So in this particular case, it will happen. Okay, how you can calculate the skewness? There can be many methods in statistical books that you can calculate the skewness of the data. An example here is given that Pearson's median skewness. It is calculated by 3 multiply mean minus median divided by standard deviation. So mean minus median divided by standard deviation. So this particular method, actually Pearson's median skewness, this method relies on the fact that how much of the standard deviation is between mean and the median values. Or in simple words, you can judge, or you can say that if we are taking the difference between the mean and median, then how many standard deviations are there in between both of these values? So this is actually the Pearson's median skewness. So this is how you calculate the skewness of the data. So what to do if your data is skewed? So if it is zero skewed, that is absolutely fine. It is good for you. But in normal circumstances, it is not. So what to do? One thing is do nothing. Um, you want to take distribution into account, and you can take a certain statistical tests like t-tests, ANOVAs, linear regression, and these kind of statistical tests actually they are not very sensitive to the skewness of the data, especially the linear regression and t-test and ANOVAs, because they rely on more on the variance rather than any other measure. So that means if your data is of little, it is the skewness in the data is not of great quantity, then you can also ignore that. But in case you want to take into account the skewness of the data, so you can use the algorithms which actually are good with this kind of data. So you might have heard about the linear regression model, but there are modified versions of linear regression models as well, which are also called as generalized linear regression models. So you can apply those models on skewed data, and they will show the promising result. And the last option is obviously you can always transform the values. You can log transform. You can take the scare root of the data as well. So there can be many possible ways. You can there is regularization, there is standardization. So you can always take into account the transformation of the variables if you have to transform the. Okay, these are some. So basically, if your data is zero skewed, you don't have to do anything. It is good for any type of analysis. But if your data is either right skewed or left skewed, then you have these four options. Just keep in mind that these intensities of the skewness is entirely up to you. Zero skewed data means that your mean and median are equal. So if your mean is 0 and or your median is 0 and your mean is 0.4, that is also fine. So some researchers think that it may not be absolutely similar or same, but they can be similar. So if they are similar, then they are considered as zero skewed data. So mild changes can be tolerated. So in either case, if your data either your data is right skewed or left skewed and it is mildly skewed, the skewness of the data is mild, then you don't need to transform the data. In either case, you do not transform the data, whether it is right skewed or left skewed. But in another case, if it is moderately skewed, then you can take the scare root. Scare root actually dilutes the impact of extreme values. So you can always take the scare root, and this transform the values into a form that actually neutralizes the skewness of the data. But if your data has high skewness, whether right skewed or left skewed, then you can take the natural log. Natural log is a very powerful transformation actually, and when you take a natural log, the values are actually they vary in a certain range actually. So even if there is an outlier present in the data, it very easily captures neutralizes the outlier as well. And if your data is extremely strongly skewed, then you can take the log base 10. So you can take log base 10 of every value, and your data skewness will be neutralized. So this is something that you use when your data is skewed to one side or other side.